Hello guys, today we are going to be talking about couple interesting laws. The laws are Kirchhoff's laws for circuit. First law, Kirchhoff law, voiced uh, the sum of currents in the network of conductors meeting at point is zero. And in other words, if we get the sum of currents E from E, for example, to N equals 0. And for this circuit, if we can uh, take, if we will take the currents, the knots or point of circuit, and current 1 minus current second minus here is plus, is it wrong, here is minus, plus is wrong, minus current third minus current fourth equals 0. Okay, for this picture. And for next picture, second rule, second law of Kirchhoff for circuit, voiced the sum of potential difference or voltages around a closed loop is 0. And second law, Kirchhoff's law, we can write as E for S, U with subscript E equals 0, this expression. Okay, and what we can do for this circuit for finding the currents in the conductors of this circuit. If we know meanings of each resistance 1, 2, 3, 4, and these sources of electromotive force, what we can do? We can adjust the system of equations. This system of equations will call as system for Kirchhoff's laws system. For first Kirchhoff's law, we should make the equations for nodes of circuits or of points of circuit. For points, equations for points, quantity of equations for points equals quantity of points of the circuit minus 1, because at the one at the at the last or at the any node of circuit equation will be as equation for currents with opposite sign, inverse sign. An example for this circuit, if we get equations for nodes A and C of this circuit, for point or node A, the current flowing to point and from point. For point the C, for the point C, similar currents and with inverse sign. And if we adjust the system of equations, matrix of coefficients of this system is will be dependent, linear dependent. Will have linear dependence. Okay, okay, and for this circuit equations, quantity of equations of first law of Kirchhoff is will be I1 plus I2 minus I third equals 0. And next step is adjusting equations of second Kirchhoff's law, is law about voltages or differences of potentials, of the potentials differences. Okay, and quantity of equations for second law will be as quantity of branches of this circuit, an example, or for any circuit is similar. Here we see three branches: branch 1, branch 2, and branch 3. And quantity equations will be quantity of branches of circuit minus quantity of equations adjusted for first Kirchhoff's law. And if we have three branches, we must subtract quantity of equations equals 1 for currents for first Kirchhoff's law, and we get two equations. We will get two equations for second Kirchhoff's law. Okay, and for this circuit we imaginary get the target for clockwise. It is arbitrary target, and for second loop is clockwise too. And direction of currents we should take arbitrary, similar like as we take this direction of target, clockwise direction in the loops. Okay, it need for choose the signs for currents in our equations. Second equation is in the system as bracket here. For first current I with subscript 1, here one resistance in this loop, this branch R1, And here we see the current of second, current 2 is inversed as current 1, and opposite the direction of our going along this loop. Therefore, this current with sign we choose with sign minus, and current second with sign minus, for multiplied by resistance second 2, 2, 2, 2, and here we plus current third is 0, and its equation equals electromotive force is clockwise like our directions. It means it wrote with plus, with sign plus, and the electromotive force 2 is plus 2, plus electromotive force second. And next equation we adjust for second loop. For second loop we can adjust the equation for current third and second. For current first, as you see, don't present in this loop, and it equals 0. Current resistance plus resistance second, sorry, no such, current 3 is right targeting clockwise 2, like going around the loop, and therefore it with this current third with sign plus in our equation, and current second with sign plus, both like current third. Therefore we put this plus. Current second, resistance second 2, and for third current third multiply R3 plus R4. Understand? And all equals equals minus electromotive force third. Second. Electromotive force second. Because this electromotive force targeting counterwise our direction. Our system is prepared, and what we can do with for our system for solving them this for solving this for solving it system we can do next step. We should adjust matrix equation. It will be seems like matrix for resistances is matrix is multiplied for matrix for current, matrix for current, matrix for resistance multiplied by matrix for currents equals this equation matrix for electromotive forces of our circuit, and it all equals our matrix for resistance. I will draw like one first row and matrix brace, and next we see here is minus R first, R resistance second, and 0, and here 0 2 resistance second, and in this point resistance third plus resistance fourth, and multiplying next step for vector matrix or column matrix for currents, current 1, current second, and current third. All these equal matrix of column matrix of electromotive sources. Here matrix exists from next points. Here is 0. Here is electromotive force 1 plus electromotive force second plus here and here minus electromotive force second. Okay, and if we replace letters in the our matrices in our equation by means of variables, we can find the currents 1, 2, 3 in our circuit. Okay, I hope you understand how can use Kirchhoff's laws for solving equations for any circuit, and I and I think it's time for goodbye. Bye bye.